7 inches tall.
Yeah. And I'm gonna have to try to set it up.
Few or quite a few. 24 million
Few.
feet tall.
All right. Yesterday, we were talking about section 4.2 to 4.3. This section is called the trig functions. Okay, the trigonometric functions. All right, now the trig functions themselves, there's 6 main types, right? There's six main functions themselves. There's 6 functions, okay? The big thing that I want to make sure is that you know the name and you know when to use one versus the other, and how do you know how to use your calculator to do it today. So that's what we're going to look at. I want to bring up one of the problems we finished yesterday with to make sure we do a nice tie into what we're going into today. Okay, so the 6 trig functions, the main 3 that we covered was sine, cosine, and tangent. Okay, so these are the main ones, and we talked about the abbreviations yesterday and what they look like on a calculator. It's SIN, COS, and TAN. Right? These are the abbreviations that you can see on a scientific or graphing calculator. Now, the main 3 have reciprocal functions, which makes the next 3, which is your total of 6 then. The reciprocal functions is cosecant, secant, and cotangent, right? Spell it right, secant, and cotangent. Now, I know yesterday one of the questions was, Mr. Ward, why do you write them in that order? I wrote them in that particular order because that's the pairings from up above. Every trig function and its pair, the reciprocal, each pairing is always paired with one of them that starts with the letter C. The letter C has to be on one of the pairs. So sine is matched with cosecant. Cosine is matched with secant. Tangent is cotangent. Every pair has one trig function that starts with the letter C. That's just how I remember it. Okay? Now, these trig functions have their own abbreviation. CSC, SEC, and COT. Okay? Now, the problem is, these are the ones we haven't talked about yet. They are not on your calculator. Okay? Just to let you know, sine on your calculator, you know, we talked about this yesterday, what it means, you know what sine actually stands for. It stands for sine of an angle, which is a trig function that on your calculator, when you type in sine, you hit like an angle after it. It automatically knows it's going to take the opposite wall of your right triangle and divide by the hypotenuse wall. Now we'll review that, like why is that the formula, but, so one of the things that we talked about yesterday, and I think one of the questions I don't know if it was Reese you brought up yesterday, was the sine -1.
Or inverse.
Was it? I don't know.
Yes, I did that.
Alright, sine -1, that is not the same thing as cosecant. They're not the same thing on a calculator. Sine -1, the inverse sine function, that's what it's called inverse because it has a little -1 on it. All this button is used for in a calculator is to help you find an angle. That's what we're going to look at today. We're going to try to look at that function to see how to use it today. The cosecant, this button is not actually found on your calculator. It's not. There's no CSC button. On some graphing calculators, like I think those Texas Instrument ones, they would have that, but it's buried in the menus. The goal today is to like show you why would you ever use that, or why would you want the cosecant button? Like why would that actually be even useful? So that's what we're going to look at today. Now, some calculators do have them because they're graphing calculators, but you can always type things into Google, and Google will actually give you results for it. Like Google is just a big calculator. You can think of it like that. Same with Wolfram Alpha, the website. It's just a big calculator. You can type in your trig functions exactly how you see it on the board. It will give you a result. So if like you're at home and you're like, I don't have a calculator, you do have Google, and Google can calculate that stuff for you. Okay? The Google machine can do it. Okay? All right. But yeah, so let's walk through this today because I did want to tie in like why would we have the inverse trig functions today? Because that was something like I just threw at you yesterday, but I don't know if you've ever been really discussed like why you'd ever choose that. Okay, and that's what I want to talk about today. All right, but before we get there, let's do a quick recap of the trig functions themselves. The acronym that I want you to know is SOHCAHTOA. SOHCAHTOA. Now, I'm going to go through the letters here because some people can't read my penmanship, sorry. The capital letters are the trig functions. S is sine, C is cosine, T is tangent. Then the letters after the smaller lowercase letters, those letters are the actual formula that you would put after it. So like for sine, and I have it written down already, sine, this is the sine function, OH comes after it. O means opposite, H means hypotenuse. So this is the formula that you have, and yes, when you type this in a calculator, you always have to have an angle after you type in sine. I know some of you have different types of calculators, so like this one in particular, the Casio. There's some Texas Instruments that have this as well. We have to have these in kind of uniquely into these types of calculators, as opposed to Larson Holy Pures. I think everyone has that, even Riley and all that stuff. Those calculators, you can just type in exactly how you see me write on the board and just hit enter. The one thing I forgot to check yesterday, which I was kind of walking around the room and checking everyone's results, we have to make sure when you're in degree mode, your calculator has to have the little D and G on the screen, or a little like lowercase d somewhere on the screen. The reason why is that we're using degrees, not radians. Eventually in the later sections, we'll do the trig functions with radians, and I'll show you how you can type that in your calculator and get the same results. Okay? But it should be in degree mode. It looked like from yesterday when I was walking around, everyone was in the right mode because you guys were getting correct answers. Because all your numbers were making sense from what I was looking at. That was another reason why I was walking around other than my video. I do need to check that you know how to type in your calculator, and that's something we're going to look at today. But now, the other trig functions, like cosine here, the second one, cosine of an angle, the A and then H, that's what the letters are. A is adjacent, H is hypotenuse. Now, on a right triangle, the adjacent wall and the hypotenuse wall are in relation to where your angle's at. Hypotenuse should always be the same wall as the longest wall, but the adjacent wall is depending where your angle sits. So that's something I forgot to talk about yesterday, and we're going to review that today. And then the last one we talked about was tangent, right? For tangent, that is tangent of an angle is opposite over adjacent. So now, all right, so for tangent, it's O then A. So sorry if you can't read that from the board, but I want to make sure that everyone has those functions written down. Now, the one problem that I talked about yesterday, and I think it was we did it with the sine function. It was the problem where we were doing a mountain with a ski resort, and we were doing the cable for the actual skiers to go up the lift, right? This is one of the problems I think we finished on yesterday, but I never really got to the final part that I wanted to discuss with you. Was on that problem where we had the mountain, right? I think we said the mountain was like 6,000 feet or something like that, right? So 6,000 feet, let's say. You know, the ski lift itself goes down to the ground, and we talked about the angle it makes with the ground. I don't even know what we used. Let's say we said it was 20 degrees. I have no idea what we even used.
It was 20.
Seriously? Okay, I didn't even know. All right. So in this particular case, we were talking about, we wanted to find how long the cable was for the lift. Okay, we wanted to find this number. Now, on a right triangle, so I get rid of my mountain here. On this right triangle, that number is the hypotenuse. The hypotenuse is always the longest side. It's the side that doesn't touch the 90-degree marker. That was something I didn't discuss yesterday. I don't think I spent any time talking about that. Where your angle sits, we're using 20 degrees. This will tell me where the opposite and adjacent is, because where that angle is. The opposite is always across the picture from where your angle sits. So if your angle's at the top, the opposite will be the bottom wall, because you have to go across the picture. The adjacent is always the wall that's next to your angle. So these two words could flip-flop, depending where your angle sits. So maybe you're up in the air and you're doing an angle of depression, you're looking down. As opposed to what I'm doing here is an angle of elevation, looking up in the air. But in my case, how I know which trig function to pick, and this is something that the later classes were asking me about, how do you know which trig function to pick? Once you label your picture, so I labeled my angle, this is my theta, and the one wall they gave me was the opposite wall, and the wall I'm trying to find was the hypotenuse, I know which trig function to pick out of the three because you always have to have 2 out of 3 numbers plugged in into your trig function. And I always label the wall that they gave me, no matter what it is. So this wall happens to be my opposite wall that they gave me. And I'm looking for the hypotenuse. So if I'm thinking about SOHCAHTOA, I have to pick this one. It's the only one that uses O and H, where at least I have 2 out of the 3 numbers plugged in. What I mean by 2 out of 3, I have the sine of my angle, so one of the numbers is plugged in, because my angle number. And then the opposite wall was the 6,000. So you can see that I'm only missing 1 out of 3 numbers out of that formula. There's 3 numbers there. Now, this is the part that I want to get to yesterday, because we finished that problem. I think we did this one yesterday, and I think it was, I think we talked about this yesterday, and it was like 17,000. It was some big number. It was something big, right? What we talked about yesterday is that the x on the bottom, we just did this little switcheroo thing, where we typed in the 6,000, we divided by the sine of 20, because we just switched the x. If the x on the bottom, you can do this little switch, because you multiply the x across, and you divide by the sine of 20, because that's just a number. And we were typing that in, we were figuring out what my x was. Okay? I don't even know what the number was. It was big though.
17,543.
There you go. 17,543. Okay, point blah blah blah. And that was in feet. Okay, so it was big. It was about 3 miles-ish. Here's the thing on this problem. The sine function probably wasn't the best function to pick, because the weird situation where the x is on the bottom. This is a case where using a reciprocal function might have been smarter. The reciprocal function is when you're doing the sine function. This is paired with the word sine, because they're paired. One is always paired with the s and c, right? So this is the sine function. It's the flip of it. So if we would have chose on this particular case to use the cosecant function, of my angle, all it would have been the perfect flip of the sine function. That's all cosecant is. You just flip sine's fraction over. So, and why I would have actually chose to do this is because if I were to plug in my numbers now, cosecant of 20 degrees, the x would have been on the top of the fraction, not the bottom. So I wouldn't have had to do that little flip. And then the opposite would have been the 6,000. And now I can solve this thing out, right? I can multiply the 6,000 across. Now here's the only issue with doing this. Yeah, you don't have a cosecant button. Now, it's not a big deal. If you have a Chromebook, which you do have, you could type that into Google exactly how you see it. I would just put parentheses around the 20 degrees, and I would just type in cosecant of 20. And it would actually calculate that for you. And it would have been the same number. It would have been the 17,543.
So why is that easier than doing the things on our test?
Okay, if you did, yeah, okay, valid question, right? If you had a computer in front of you, like not a calculator, but you just had a computer, you're doing homework and you know you have your computer next to you, you wouldn't need to necessarily type this in and do the whole switch thing, when you could have done an easier way of doing it by just multiplying. You wouldn't have to deal with fractions and dividing. Because I'm not lying here. The older calculators, the Casio, I'm going to say older, the calculators that don't have a menu driven, typing this in is actually kind of a pain. Because what you have to do on one of these is you actually have to find out what the sine of 20 is first, because you can't type it in all at once. You have to find the sine of 20 first, and then take 6,000 and divide by that. That's the correct way to do it. There's some other ways to do it. If you put parentheses and stuff, you can get around it. Yep. But the idea on this particular problem is, if you had a normal calculator in front of you, yeah, this makes more sense. You have. No. But I'm saying, if you had a calculator in front of you, this would be the way to go, because you don't have a cosecant button. But if you had a computer, this is the way I would have went. It's faster. I don't have fractions. I don't need to worry about parentheses. I can just type in exactly what I see there, and it spits out an answer. Especially like on my graphing calculators, I can type that in, because it allows me to, because in the menus I have the reciprocal function.
Mr. Ward, you should type it in.
Okay, it's the same number.
Okay, I know, but I just
All right.
want to see you do it.
Now, it does give you the same results. Now, if you were gonna choose to do this one, I would say if you had a calculator in front of you in class, yeah, every day I would just do the normal trig functions. But this is the purpose, what you can do with it. You could do the reciprocals if you had the luxury of that button. It wouldn't have a fraction involved. All right, questions with that? So that, I wanted to show you that yesterday. I didn't talk about the reciprocal functions. What would the purpose be? This would be like a perfect example of when you choose to use it and it'd actually be easier. That you could multiply the 6,000 across instead of doing a weird fraction and doing a weird switch. Because some people won't like that. It makes more sense for having the number on the bottom and just multiplying it to the other side. As opposed to doing two steps, two switches. But it's not a big deal. All right, today I want to do a couple examples where you get to try out some by yourself, and we're going to do 2 new problems today where we have to find an angle, and one of the problems you have to find a wall, but you're not given angles. So we're going to talk about that. Okay? Questions? Okay, let's do an example here. So, and I'll give you kind of luxury of making up a problem here in a minute, but for right now, we're gonna stick with the numbers I'm gonna provide you because I want to see if you guys can type this in and get the right answer. Okay? All right. So first of all, let's do a problem where we're gonna find the height of a building. Let's say.
Let's make this a big building.
Okay, so we're gonna do a kind of a larger building. So here we go.
1,776 floors or feet.
No, floors are not 1 foot, they're 8 feet, so you have to multiply that by 8 or 9.
All right, so here's my building. All right.
If you have a big head, you can't crawl.
Okay, here's my building. Okay, and let's say that we're putting a ladder up against the building itself. So here's my ladder. So.
Looks like a 38-degree angle.
Okay. Okay, we'll use 38. All right, so if we're doing a 38-degree angle, and we're so many feet from the building itself. Let's say we're 25 feet.
5,280 feet.
Okay, not degrees, but feet. All right, so we're saying 25 feet from the building itself. The goal is, I want to find how tall the building is. Okay? So, this could be one case we could do it. Another case, maybe you know the size of the ladder. Okay, so you could fill that number in. So, instead of maybe knowing how far you are from the curb, maybe you just know the ladder you have is a 50-foot ladder. Okay, something like that. We can make any type of problem you want, as long as you have enough numbers where you could plug in to one of your trig functions, one of these, excusing the reciprocal functions, we'll stay away from those today. But as long as you pick a trig function that you can plug in 2 out of 3 numbers into it. Okay? Now, do you guys want to do the one where I was 25 feet from the building, or you want to do one with a 50-foot ladder?
50.
50-foot ladder? Okay, I heard 50. She was quick on the draw.
Oh my
Okay,
god.
so, if we're going to pick one of the trig functions, I need to label the walls to know which one to pick. So I'm using the 50-foot ladder in this case. Okay, so, in this case, it looks like this is the opposite wall of my angle. That's the one I'm missing. This is the hypotenuse of my right triangle. Because that's the wall that doesn't touch the 90-degree marker. So in this case, it looks like this would have to be the trig function that I'm picking. Okay? Because the reason I'm picking that one, it's the only one that uses opposite and hypotenuse. So, sine 38 is the opposite over hypotenuse. Opposite over hypotenuse. Okay, questions on the setup? Again, how I figured out which one to pick, as I labeled my picture, knowing that it was O and H on that picture, that means I had to use this trig function. It's the only one that has O and H in it. Okay, now, typing this in, what do we have to actually do to actually calculate this?
Switch and then just multiply by 50.
Multiply 50 across. Okay, if we multiply the 50 across, we'll get 50 feet times the sine of 38 degrees. And this will give me my answer. Now, what's the label going to be? Feet. Okay? The sine of 38 doesn't have a label, but the 50 did. It had feet, so the label will be in feet. 50 times sine of 38, what do we get?
30.76.
That's 30.76. Is that what everyone's getting?
Yes, yeah. 7, 8.
7, 8, okay.
Yeah, 7.6.
Okay, we'll go 7, 8. Some people confirmed. Alright, now, does the number make sense? This is something we didn't think about yesterday. That number should make sense to you because it had to be smaller than the hypotenuse. The hypotenuse is the biggest wall. So we knew that, you know, the building itself had to be below 50 feet. The ladder was at a diagonal. It is definitely taller than the building itself. Okay, now, putting that up against the building, putting this up against the building itself, like comparing, the building had to be smaller. The other reason why, other than just knowing that the ladder is the biggest wall, this is a really kind of smaller angle, 38 degrees. If you're thinking about a right triangle, the biggest angle gives you the biggest wall. 38 is potentially the smallest angle of that triangle. Because this, the other angle in this picture, would have to be 52 degrees. Now how I know that? There was a property in geometry we talked about that the remaining two angles of a right triangle have to be complementary. So that the two remaining angles that are in this triangle, that's the acute angles, these two, have to add to make 90 degrees themselves. So I knew that the other one had to be 52. So what that tells me is that the actual distance on the ground, this distance down here, is actually longer than the building itself. That's what it's telling me, potentially it is. Because the idea is that the angle that's bigger will give you a bigger wall across from it. The opposite wall will have to be bigger the bigger the angle it is. So that means that the building itself is actually the smallest number on that picture. Is it drawn to scale? No, it didn't have to be. As long as you know what you're calculating. All right, the next one. I'm going to give you kind of leeway to do this, but I want you to draw a picture where you draw a water tower. Okay? I want you to draw a picture of a water tower. I want you to make up the height of the water tower that you want. Don't say it out loud, make up any height. And I want you to be standing on the ground looking up at it, and I want you to pick any angle that you're looking to the top. Okay? Try to pick another angle other than 45.
I was going to pick 45.
Don't
pick 44.
Don't pick 45.
I
Okay,
do
so
44.
pick, that's fine. Just pick another angle other than 45 because we talked about it yesterday. If it's 45, the height of the building itself is the same as the distance away from it.
Technically, can I do 89.9?
Okay, fine. All right, here's what I want. I want, once you have, you know, your angle, what you plugged in other than 45 degrees on the ground, that's where you're standing, and the water tower itself, you can pick your height of your water tower. I want you to figure out the distance you are standing away from the tower, the distance on the ground. That's what I want you to find. I'm going to walk around the room, I'm going to check your numbers, what you picked for your angle, what you picked for the height of your water tower, and I want you to find the distance on the ground. And I'm going to walk around, I'm going to double check your numbers and see. I want to see the trig function itself written on your paper, the actual formula, and I want to see you type it in to see what your number is. Okay?
Oh, mine's really good.
Divided by 10, 37. Okay, I agree with that. And why did you know this number had to? Why do you know that number on the bottom had to be an X? Why do you know that?
Because that's adjacent and it's opposite over adjacent.
Good. Okay. And what was the number you found?
295.9 feet.
So you picked a tower that was 223 feet tall.
Yeah.
How many feet is that?
Okay, sounds good. Thanks.
I have no idea.
Smith, what do you got? All right.
Got
so
a
you
100-foot water tower with a 89.9 degree angle.
Okay, so you're pretty steep.
Yep.
All right, and then what was your formula that you had set up?
I have tangent, but I have 100 divided by tangent of 89.9.
And what was your distance away from it?
0.174 feet.
All right.
So about 2 inches.
All right, good. All right, fine. Does it make sense though with your picture though?
Not the way I drew the picture.
Not, so it's not on the scale. But, okay, yeah. So, okay, good. Okay, good. So you picked a 50-foot water tower and your 32-degree angle. Now, why do you know to put the X on the bottom?
Because that's the unknown angle. Or unknown.
That's your unknown.
Length.
And so a tangent would set that up that way. And you typed in your calculator. Yeah. And so now what's your label on that? Safety. Perfect. All right. And does the number make sense? So, okay. Yeah, I agree with that. All right. So you picked a 700-foot water tower?
700 kilometers.
kilometers. Okay, you went with kilometers. Okay, and then your angle is 35 degrees. Now, you set up your tangent function. Here it is. Now, how do you know to put that x on the bottom? How do you know that?
Because Toa.
Dylan? And now, did your answer make sense?
Yes.
Why?
It looks about right to me.
It looks about right. Is your picture drawn to scale? Is that why it looks right?
Yes.
Oh, okay. We'll go with that then. Okay. We'll go with that. Yeah. Yeah. All right. You got. Okay. So you picked how many feet tall is that? I can't even see.
50.
50 feet. Okay. So you went with 50 feet. That's a Garner water tower.
Yep.
Perfect. All right. And you picked a 54-degree angle. Now your number you got was 36, and so we'll see you typed it in. Now, does that number make sense to you?
Yes,
Why?
because this angle is going to be smaller than that angle.
Okay. So it'll give you a smaller
It's going
number.
to be smaller.
Okay, good. Okay.
Mr. Ward, how many centimeters in an inch?
10? 8? I don't know. 8? I don't know. I'm making up. I don't know the conversion.
I'll look it up. This is 12.
Okay. So you went with 10-inch water tower?
Yes.
Okay. And so you went with 30 degrees, and you.
Yes.
Why do you know to put the x on the bottom?
Because I got the formula up here.
Oh, okay. So you got the formula. So there's your formula for tangent.
Or you
put
could
the
use
adjacent.
Toa.
So then, what do you get for your final number?
17.32 inches.
Okay. So your distance away from the object is larger than the water tower itself. Why is that?
Because that angle is smaller than 45.
Okay. Good. Yeah. All right. Good. Okay. Good. Alright, so you went with a 51 foot.
Yeah, 51 feet, 39
Okay.
degree
And
angle.
then so that's what you typed in your calculator. Now, does
Yep.
that number make sense to you?
Yeah,
41 feet.
I
Okay.
think,
And,
yeah.
Okay, why?
I don't know because the angle's smaller than 45. I have no idea.
Because you went 39, so you should get 51 over here. But this angle's big, right? You said this was going to be, that was a bigger angle? Shouldn't this be a bigger wall?
Justin, was it 10 centimeters in an inch?
Type in your calculator.
10 centimeters.
Okay. 51.
2.54, but I just did 2.5. I'm not about that
4.
extra decimal type thing.
41. Is it
Yep.
in DEG mode? Yeah. Hinge on 39, you went 39 degrees. Okay. 51 feet.
Reese, come here.
I don't know what I did
Hey,
wrong.
we're gonna bring these up.
The same answer.
Go sit over there. Go sit over there so you can sit your feet in.
Okay.
Mine was 100 feet tall and my angle was 89.9. So I did 100 divided by tangent 89.9. 100 feet tall, 42 degree angle, and so I'm 111 feet away.
And does that number make sense to you?
Yeah.
Reese.
Wait, I already got yours. What am I doing? Alright. Let's just double check. I'm skipping the graph because that graph will not look right on the camera. Okay, so you picked a 50 foot and you picked a, what is that, 30 degree?
It's 30.
Okay, does your number make sense though? You got 51? Why?
Because I calculated it.
So you calculated it? So your number is greater than your water tower itself?
Yep.
Okay. Any other reasons why other than just calculating it? Oh, okay. Alright.
Oh, it's supposed to be
Oh, there you go. So we're talking about angles now. Alright. And you went at 16 foot, you picked 15 degrees. Alright. That's good. Alright. Okay, hey. Hey, sit. Sit.
Yeah, I don't know.
Sit, please. Alright. Okay, so I want some numbers here. So we have a water tower. So here's my crazy water tower, Garner water tower. Alright, so
Okay, the wall is 51,
51 feet. Okay,
and
You'll never see that.
angle to the top.
the top angle,
This angle.
that angle, 39 degrees.
39, alright. Hey, so, here's what we have. We have the water tower is 51 feet. We're at a 39 degrees looking up. That's an angle of elevation looking to the top. I want to know how far you're staying away from the object. Okay, now, not to pick on,
on Briley here. The numbers we came up with. I think the answer was 41 feet. Okay. I want to discuss why that number doesn't make sense to me. Because I was trying to ask
The
questions.
angle's bigger.
Okay, yeah, the top angle, what was it? What was the top?
51.
51. Okay, so we said this was going to be 51 degrees. This should be a bigger wall than that. Certainly, right? Should be. She was typing her calculator, and it kept telling her 41 degrees. The reason why, you were typing it in wrong. One simple thing. Now, hey, let's talk about, okay? When you do TOA, right, because she was doing tangent of your angle, tangent of 39 degrees,
Okay, I know now.
is 51, the opposite for her adjacent.
Yeah, I know. I did it wrong.
Yeah. Yeah, you switch these around. Good way to finish. You guys are terrible. Good learning moment, though. Good learning moment.